This is a question from StringCat. We'll work backwards to find z-scores, means, and standard deviations, so it's a little bit backwards. Imagine if 5% of babies can walk by 10 months and 75% can walk by 13 months, what is the standard deviation and mean? The problem requires us to use the z is equal to the observation minus the mean divided by the standard deviation. Let's start with the first question. Draw a bell curve, and along the x-axis is the months to walk. In the middle we have the mean, but we don't know what it is, and that would be mean months to walk for babies. So we have to find 5% of the area under the curve. And at that point in time, or that area right there, what is the associated z-score? It turns out to be negative 1.645. Now I'm going to tell you how I got that. So 0.0500 is somewhere in the body of the table, and that's what you have to do. You have to find it so you can find the z-score. I recommend finding a column and looking down until you get something close to 0.05. Reading to the right, find 0.0505, and you have 0.0495, and you got to go back and forth. Which one is it? In this case, you have negative 1.64 where these two lines intersect, and also negative 1.65 where these two lines intersect, or shaded areas. So the value between negative 1.64 and negative 1.65 is negative 1.645, just right smack in the middle. Now I have the formula to calculate the z, and so it's negative 1.645 is equal to, where that is the negative 1.645 I'm talking about. So I have 10 minus the mean divided by standard deviation, and that's the 10 months. That is also the observation that corresponds to that z-score, of course. That is our first equation, and we will have two equations. We also know that 75% of babies can walk by 13 months. So now I have 75%, or 0.750. I'll shade in the area under the curve. This equates to a z-score of 0.675. You should try to find that 0.675, that z-score, in the back of your stats book so you can follow along. Now I take this z-score and I use the same formula as before. So I have 0.675 is equal to 13, which is 13 months, minus the mean divided by the standard deviation, which I don't know yet. The 13 months is the observation that goes with that z-score. It's 13 months to walk right there. Now I have two equations and two unknowns, so I can solve. I'm going to solve for the standard deviation first. So I multiply both sides of the equation times sigma, or the standard deviation, that symbol there. Those cancel out on the right-hand side. I'm left with this equation. I subtract 13 from both sides of the equation. The 13s on the right-hand side cancel out. So now I have the following equation. Do the same thing for the blue equation. I multiply both sides by sigma, or the standard deviation. And now I'm left with the following equation. I think. There it is, right there. Just this value here, the negative x bar, or the mean actually, is in both equations right there. So that value, or that symbol, is exactly the same on both equations. So I'm going to take 0.675 minus 13 and plug it right there. So I take 0.675 times sigma minus 13 and move it over to the other equation. Just like that. I can remove the parentheses and rewrite the equation. Now I take the 10 and the 13 and combine those two numbers. And I'm left with the following equation. I'm running out of space, so I got to start over on another page, and I'll rewrite the equation over. And I'll write the other equation because we don't want to lose track of that. Now I subtract 0.675 sigma from both sides of the equation. And of course, on the right-hand side, where I slash it through with a red line, that equals 0. I'm left with the following equation. I want to solve for sigma. Now I multiply both sides of the equation by 1 divided by negative 2.32. Which gives me sigma is equal to negative 3 divided by negative 2.32. Simplifies to sigma is equal to 1.3. Now I take this 1.3 and I plug it into this equation up there, the orange equation, or the tangerine colored equation. Now I plug in the actual value, I rewrite the equation, and I move up the 1.3, so you can see where that goes right there. 0.675 is equal to 13 minus the mean divided by 1.3. Now I solve for the mean, or x bar, the mean, let's just say the mean. Multiply both sides of the equation by 1.3. 3's cancel out on the right side of the equation. I'm left with this equation. 0.871 is equal to 13 minus the mean. Subtract 13 from both sides of the equation. As you can tell, I'm getting worn out. Which gives me negative 12.1 is equal to negative x bar, or mean. That simplifies to 12.1. That's our mean. And the standard deviation is 1.3. A whole lot of steps to learn about babies.